As part of my using integrated software across the curriculum class, we read Stephen Johnson's Where Good Ideas Come From, The Natural History of Innovation. The text examines the history of various inventions and how they came to be. One of the most interesting chapters of the book is simply named Errors. This chapter examines how various inventions came to be outside what would be the typical process. Inventions and ideas such as the triode, plastic, cosmic noise are just several that have come to be by accident or error. These byproduct ideas have come to eclipse the original ideas that they were based on or investigated. The first example takes place in the beginning of the year 1900 with a young inventor named Lee De Forest. His work originally began not with direct investigation, but rather simply translating technical documents in the field of wireless technology. The technology had only been discovered within the past 15 years by a slew of inventors who were investigating different technologies with the wired telegraph. While working with the spark gap transmitter on September 10, 1900, De Forest noticed that a nearby flame increased in intensity when electricity would pass through the transmitter. De Forest assumed that the change in flame intensity was caused by the electromagnetic pulse. This idea would ferment in his mind for the next few years, until 1903 when new experimentation would begin. His new experiments involved placing 2 electrodes in a gas-filled bulb. However, he met with little success initially. It was not until a third piece, called a grid, was introduced several years later that he finally came upon a device that would greatly amplify audio signals. The device would be named by De Forest as the Audion. The interesting part of De Forest's discovery is that his original assumption was in fact wrong. The flame's increase in intensity was not caused by electricity passing through the spark gap transmitter, but instead caused by sound waves from the transmitter. It was not until years later that researchers discovered that the Audion was more effective when the gas was removed from the bulb. A third electrode was introduced by researchers, and the triode was created. The triode would become the first electronic amplification device and would lead to the invention within a short time of the vacuum tube. The simple Audion discovered by De Forest, who had mistaken an increase in a flame, would eventually lead to modern-day computers. Johnson points out correctly that there is a long string of failures for every invention or discovery that has been put forth. If it was not for some of the most simple mistakes, such as an open window, the lives of millions would have been lost. In the case of the open window, an invasion of mold on cultures of Staphylococcus led to the discovery of penicillin. Our understanding of photosynthesis comes from a failed experiment conducted by Joseph Priestley. He had assumed that a mint plant placed in a bell jar and deprived of oxygen would begin to wither and die. When the plant survived, and in fact thrived, it made Priestley curious as to why. Eventually, this would lead to our understanding that plants expel oxygen. 2 of the most interesting discoveries that have occurred have happened in the field of astronomy. Both the discovery of cosmic background radiation and planets outside Earth's solar system were initially blamed on defects of the astronomer's tools. We will begin with the story of Arno Penzias and Robert Wilson. While at Bell Labs, Penzias and Wilson worked on a microwave receiver for a horn antenna. During their work, they encountered background noise that was typically blamed by most astronomers at the time in equipment feedback. Penzias and Wilson checked the telescope and discovered a large amount of pigeon droppings. They set to the task of cleaning the antenna and exterminating the pigeons. However, the now clean and pigeonless antenna continued to suffer from the same background noise. Having ruled out all outside sources of the radiation, they published a paper documenting their findings. Their research was then examined by Robert Dicke, a researcher at Princeton U. He was able to identify the noise as the remnants of the Big Bang. The story of Peter Van de Kamp is an example of a discovery that was years later disproved and then decades later found to be indeed correct. In 1938, Van de Kamp noticed an orbital wobble occur while studying Barnard's star. Based on the observed wobble, he claimed that a large gas giant was orbiting around the star. At the time, this announcement caused a stir in the astronomical community. Attempts by other researchers to observe the wobble failed, and an examination began on the telescopes used by Van de Kamp. It was found that the timing of the wobbles corresponded with the timing of modifications and adjustments made to the telescope. The battle between Van de Kamp and his detractors would continue until his death in 1995. The Barnard star affair was finally put to rest in the very same year. In 1995, astronomers announced that the first planet to orbit a star was detected. In the years since the first confirmed discovery, over 543 candidates for extrasolar planets have been identified by both scientists and amateurs. Scientists have taken great advantage of the errors that have occurred, allowing them to explore new fields of science that may have otherwise taken years or decades to discover. Mother Nature has also taken advantage of the errors that occur over a long period of time, allowing for both flora and fauna to evolve. In his 1868 book, The Variation of Animals and Plants Under Domestication, Charles Darwin proposed the idea of nature introducing hereditary directed variation. His system of directed variation would be proved wrong and is now considered one of his greatest errors. Darwin erred by not allowing enough freedom for random errors to occur. Scientists have also learned of the danger of having too many errors or having errors occur too frequently. A creature that would be unable to pass down a stable genetic base would die out quickly within the first generation. Researchers have found that nature has optimized the transcoding error rate. The current rate of error for humans is estimated by research to be around 1 mutation for every 30 million base pairs. Each set of parents would therefore pass down about 150 mutations. These mutations have allowed for mankind to adapt slowly over time and flourish in an ever-changing environment. We can look back and find some amusement that many of our most important discoveries came about by going down the wrong path and being too stubborn to turn around. Other innovations came about due to simple luck or a case of misfortune. It is a credit to the researchers who were able to take their failures in stride and to continue on.